I hope you can hear me, and let's start this presentation. So as Sigmund said, it's about data warehouse migration, and just a little bit introduction. Our site, ingatlan.com, is the real estate listing, market leader real estate listing site in Hungary. It's a well-known brand. We have 150 people right now, and our data team consists of 6 people and 1 data engineer, that is me. And about the data warehouse migration, the old data warehouse was running in PostgreSQL, and we had the extract part of the ETL process with the custom Python scripts written in Python 2 by an ex-colleague. And once it arrived in PostgreSQL, then we ran a bunch of stored procedures orchestrated by Airflow to get to the tables that the reporting tools such as Tableau can use. And we changed the whole system that you can see on the next slide. So hopefully you get a good glimpse of it, and I will go from left to right to explain what's going on. So first of all, we have different event collectors that run in the browser or in the application server code that sends events to a collector that runs in GCP on a Kubernetes cluster that periodically loads the data into BigQuery. Also, we have Firebase export for our mobile application, and we use Google Analytics also, and it has the BigQuery export with the GA360 package. Also, we have some custom Airflow scripts that copy data from Salesforce and from some Google Sheets that the financial department updates on a monthly basis. But the main thing today is about the production databases that you can see on the left, and we want to replicate that data as soon and as performantly as possible. There are a couple of tools that now you can use just as a software, as a solution process or a tool, such as Stitch or Alooma or Fivetran, where you basically set up a connection to your source data source that can be a relational database, or it can be different SaaS solutions like Jira or Stripe, or you name it. And just with a few clicks, you can start the different extractions. And there are 3 different ones that you will see in the next slide. Full table that always copies the full table, and that's not that performant. You can also use 1 column, and that's like an updated at or a created at column, that tells you what changed since the last time you replicated the data. But the most cutting-edge solution and the most performant is the log-based solution. Basically, it's like a replication. It's reading the write-ahead log of the different databases, and it uses the replication through that. So basically, every time that you need to you want to replicate, you are only copying the data that has changed since the last time. So not like the full table. If it's millions or billions of rows, then it would be rather expensive and also time consuming. So basically, you're just focusing on copying as little or as few rows as possible. Basically, that's done in our case with both Stitch and Alooma. Alooma was bought 2 years ago by Google, and its solution will be baked into a future Google Cloud product. And the current offering will be sunsetted, and also the users such as us will be migrated to the new solution. And Stitch is also a pretty popular solution for this. Basically, it helps you not to get bogged down in the small details of getting data from A to B, rather focus on the whole solution and basically helping your organization and not making yourself other software engineering challenges. And once the data is in BigQuery from all these sources and in different ways you can get it in, then we want to do the T of the ETL or ELT part, and which is transforming. And we are using and very pleased with DBT, database tool. Basically, it helps you with software engineering best practices to transform your data in a really easy way by building modular models, basically SQL transformations, and helping you orchestrate the running, and also helping you do implicit references, and that will help you build up a hierarchy. And the orchestration for that is done in our case with DBT Cloud. That's their software as a service solution for DBT, but otherwise the whole thing is open source. And once we transform all the data with DBT and we optimized and we use the Kimball method with facts and dimensions, then we can start making different reports, either with Data Studio, if it's like a one-off report that just needs to be done quickly, or for the more serious ones, we use extensively Tableau. So what were the results from this migration? I'm spoiling, the end of the presentation. I just want to get to what we really did with this new architecture. Basically, the daily processing time shrunk considerably by orders of magnitude, from 2.5 hours to only 7 minutes. And also in one case, it was one query used to be on Postgres 47 minutes, and now it's 26 seconds on average. Also, we can replicate the data because it's not a full table replication anymore, and an hour, every hour. So we can have fresher reports for the financial department or other areas in the company. Also, due to DBT and due to other considerations, we introduced some software engineering best practices, like everything being under source control, using merge requests in GitLab, using CI and CD solutions, so that most of the things are automated and easy to use for our analysts. Our operational costs were greatly reduced because of using BigQuery, because of not really doing things that so many other people have already done and can be just easily taken off the shelf and used as a software as a solution tool. And also not having to keep people around just to make sure, like a DBA or a sysadmin, for making sure that the Postgres is functioning, because BigQuery, the data warehouse, is a no-ops solution. So, or people that used to do that can focus on other areas in the DevOps sphere. Also, I will get into some documentation best practices that we try to employ, and it helps us with a centralized solution through DBT's side. And also, due to BigQuery's information schema, we have a much better metadata about query usages, query statistics, what tables are not used anymore, which report uses which table, can we delete that table, or something is going to crash or not. So all of these are done because these tools easily provide an API or a solution to just get a glimpse into it and take advantage of it. So as I told you about data replication, you have full DOM, incremental or log replication, or CDC, change data capture, that you might be familiar with. It's an old story. It was even available in Oracle 9G or something like that, but it's getting second time to shine recently with Stitch and Python and things like that. These are the solutions, or you can go a bit more of a homegrown, or with the Singer tool, or one of the companies did something on top of Singer, without actually offering it as a software as a solution. So you can just go with that. The transformation, this is our DAG DAG, directed acyclic graph. These yellow ones are the sources, the source tables that we rely upon. That comes, as you saw on the previous slide, from many different places, mostly from our operational databases, but sometimes from Google Analytics, sometimes from our event-based collectors. And we use Dataform, but there are other tools like Dataform, that's a bit like DBT. Sorry, we use DBT. And also there's a UI-based solution called the GCP Data Fusion that you can do transformations with. But DBT is getting really popular in the last 1 year, I think. We started using it about 2 years ago, and some features were missing back then, but now it's really handy, and something that you've been thinking about is already there because someone else had already thought about it. So we can just use that. And also we wrote some custom scripts where something was lacking. So it's SQL based that's getting more and more popular. In the last couple of years, it was a bit like every database had its own language and something a bit like SQL and QL at the end, but it wasn't SQL, and then everybody had to learn something new with its syntax. But now it seems like that everybody thinks that, okay, let's just go back to SQL because most of the analysts and business people know it much better than writing it in Python or in Elasticsearch's unorthodox query language. DBT offers a really nice testing suite that helps you with this modularity and making sure that you have the primary keys and unique constraints even in a data warehouse when you are dimensionally modeling something. And also it gives you some nice documentation features. Yeah, a few querying tips about BigQuery. Basically, the main solution or the main pricing is pay as you go. So basically, you are paying for the queries that you run. Also, if you're a big customer, then you can buy slots, and then you have a flat rate price. But we are much smaller than that. So basically, we are paying for every query that we run. That's not coming from caching. So you have to be conscious about only using the columns in your SQL statement that you really use, because it's a column-based solution. So it's going to be faster, and it's also going to be cheaper. You need to take advantage, or you should take advantage of using partitioning and clustering. So you are only reading the data that you really need. You can use it with different date columns or timestamp columns, and also now with integers. You can see in the UI and also with this dry run extra how much the query would cost, and if you think that it would be too much, then you can think about how to optimize it, and you can ask your colleague that is it a good one, or we should be a bit more careful. The limit and where clauses are not going to change the query cost, so even if you are just reading the top 5 rows, you're going to pay for the whole table, so keep that in mind. Now with clustering it's a bit easier, but still better to be safe than sorry. And also use the preview tab instead of the select asterisk or select star because it can be sometimes expensive. But if you have some cost control set up in your GCP project and you are mindful about these caveats, then you can run a really efficient data warehouse with small prices. So I highly recommend it. Yeah, and about documentation, it's always a pain in the neck, pain in the ass. Like, what's this table about? What does that column mean? When was it last updated? Who's responsible? And we have many different systems and a lot of source tables and a lot of models, and we want something centralized where we can read all this documentation. And because it used to be in Excel, sometimes in Google Sheets, sometimes an ex-colleague knew it, but it wasn't really good in the first place. So we set out to centralize and normalize it. And there are many different tools to do that too. Google Cloud's data catalog, Weaveworks, Marquez, Lifts, and Munzen. LinkedIn also has something just specifically for Metabase. I think Facebook too, that they have open source. But since we already invested in DBT, then we went with the DBT doc site, which basically you just document your tables and like models and sources with YAML. That's everybody knows YAML, everybody knows SQL, so basically everybody knows Python. So it's really easy to use DBT. And we set out to measure somehow like where we are in this process of really centralizing and normalizing the documentation. And then we had to come up with some score so that we can improve it. And we decided that the table has proper documentation if the table has at least a line of documentation in all its columns. And also, like for a data source, that we just count the tables that have proper documentation, and we divide it by all the tables, and then we get a score like 60% of our tables are properly documented. Sometimes it's not that important to document all the tables because it's just a one-off thing and you're not going to need it. So we differentiate between critical and less important tables. So we keep in mind that or try to focus on the critical tables so that people can easily use it and get around and navigate in the data warehouse. And also if we have more time, then we do the rest. And it's a small slide, maybe you don't see it, but we have a little GitLab badge with this score. So for instance, for the source in this DBT demo, we have 60%, and with the models only 50, and it has a different color. And also it kind of motivates the analysts to write the documentation so that you can keep it in 100, or you have a different kind of a badge. So this is about documentation. And a few references for BigQuery. Functional Data Engineering is a really, really good article by the creator of Airflow and Superset, Maxim Bushamin, that I really want to emphasize that if you keep that in mind, how you build your models, either in Airflow or in DBT, then and make it idempotent and functional, then you can leverage a lot of nice things along the way. And stitch data and DBT are also featured in the references.